triangles. We're going to start with ways to prove triangles similar. So in the past, we had to prove all of the sides and all of the angles were similar. But now we get to have a few little shortcuts. And so these are just quicker, faster ways to prove that these two triangles are similar. And remember, similar means all the angles are corresponding and congruent, and that the corresponding sides are proportional. So let's start here. There's only 3 of them. Let's start with AA. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. So this is the easiest one of all. You're looking at the picture and you're going to say, do they have 2 sets of angles that match up and are corresponding? And so you have S and M, that's one set. You have R and L, that's your second set. And so do you have enough? And the answer is yes, because you have to have 2 pair. Now, remember, we know the third angle theorem tells us if 2 sets are equal, then you know the third set also has to be equal. And so we know technically all of them, but we don't have to prove them all. So if we know 2, then we're good. So we happen to know angle R is congruent to angle L. Angle S is congruent to angle M. And therefore, the triangles are similar. So SRT, put your new symbol for similar, to MLP. Okay, so now it gets a little bit more difficult, but not too bad. It's better than having to prove everything. Let's see, if an blank of one triangle is blank to another angle. If an angle, let's see if I can get my pen to work. If an angle of one triangle is congruent to an angle of another triangle, and the blank that includes the angle and the sides that include the angle are proportional, then the 2 triangles are similar. Okay, so I'm going to plug some numbers in here just to make it more understandable. So if this is 4 and this is 3 and this is 8 and 6. Okay, so this is a picture and you're trying to decide if they're similar. So first of all, do you both have an angle in common? Sure, you have A and you have Q. So that's something you have to look for. So there's Q is congruent to angle A. Now you have to prove the sides that are on both sides of the angle. So for instance, the angle A is made up of those 2 sides there in blue. And angle Q is made up of these 2 sides. The angle it's called being included. Do you know the measurements of all the sides that are in blue? Of course you do. Now, are they corresponding? Now, you can start with either triangle. I'm just going to start with the one on the left. And I say 4 corresponds with 8. And then I'm going to start with the same triangle again and say 3 corresponds with 6. And I know all of those equations, both of them, reduces down to 1/2. They have the same scale factor. So they are proportional. So I'm able to write my similarity statement. Triangle ABC is similar to triangle QRS. Okay, so we have 2 ways so far. We have AA similarity and we have SAS similarity. And now we have SAS, now we have SSS. So there's 3. So on the third one, if the 3 sides of 2 triangles are proportional, then the two triangles are similar. Okay, so again, I'm going to put some just easy numbers in here. Let's do 1, 2, 3, and then 3, 6, 9. Okay, so on this one, you're not proving any of the angles. You just have to show the sides. Now remember, we actually did this before, but we had to prove all the angles and all the sides. But now we're just proving sides. So this is where I used to always say, find a triangle, I don't care which one, and list the sides from smallest to greatest. So we have 1, 2, 3. And then take the other figure and list it from smallest to greatest. So it's 3, 6, 9. Now, do they all reduce to the same thing? Take your calculator and divide them out, or just reduce them. And they all reduce down to 0.3 repeating, or 0.3. So they're all the same. So they're proportional. So we know that they are similar. Okay, so I wrote a similarity statement. Now here's where it gets tricky, guys. We're going to have these pictures here, and you have to decide whether or not they're similar. So some of the information is, you have to remember things from first semester. Now, I see here, I'm highlighted in yellow, that I have lines that are parallel. Why does that matter? Well, anytime you see parallel lines, they're trying to give you a hint that you have some congruent angles. Now, if you guys will remember back, we had a chapter where we talked about parallel lines, and then we talked about transversals. So hopefully that sounds familiar. We had alternate interior angles. So we know B and C are congruent no matter what, just because of this information of being parallel. If the parallel symbol wasn't there, then we wouldn't be able to make this conclusion. Now, going the other direction, there's a transversal going this way. So I'm going to erase the blue line. So we have the parallel lines and the new transversal. We also have a set of corresponding angles going that direction. Now, guys, you have to prove two angles. Did we prove two angles? We certainly did. Now, someone might say, what about vertical angles? You know what? Vertical angles are fine. If you looked at this and you said, oh, I see vertical angles here in the middle, then that could have been one of them that you chose. So as long as you're able to prove at least two of these, then you're going to say, yes, they're similar because of angle-angle similarity theorem. Now, what's the direction say? It says tell whether or not it is similar. If so, write a similarity statement and name the postulate or theorem. Okay, so we already named the postulate or theorem. So now the similarity statement. Now, you get to choose. Pick a triangle, put it in any order. I'm just going to pick a random order, A, B, E. Now, this is where you have to go slow. A corresponds with D, B with C, E with E. All right, so we're finished. Now, we're going to move on. Remember, similar means they're the same shape, but they are different sizes. Like one's a mini me of the other. Now, as soon as you look at number 2, do they even look the same size, the same shape? And hopefully not. Okay, so I noticed they both have an angle in common. And so if they have an angle in common, let's look at the choices. You could do it AA or SAS. Now, if you had a SAS, you would have to know two sets of sides. Now, I'm going to highlight in blue. Do we know anything but those two sides? And we don't. You would have to know that in order to prove it. Remember, similarity means they are proportional, not necessarily congruent. So there's several things wrong with this one. So we're going to say this is not similar. And why not? Because we don't have the right information. We can't prove the second side proportional. or another angle is congruent. Okay. Looking at the next one. So hopefully when you look at this, you can see more than one triangle. I see two triangles. I see this big outline of a yellow one. And then inside, I see this green one. Now I see something else. I see parallel lines. Remember that little arrow means parallel. So why do we care? Well, guys, if this is your transversal there in blue, we can do the whole thing about corresponding angles. So technically, angle L is congruent to angle O. So that's good. Can we prove another angle, or can we prove the two sides? Because we should either prove it with SAS or AA. And I mean, they don't tell you we need the angle measurements or side measurements. So what should we do? So let's go back and let me erase some of these lines. All right. So when there are two triangles here, do you guys notice that the green triangle and the yellow triangle both have angle N in common? So angle N does not change sizes from when it's the green triangle to when it's the yellow triangle. So technically, angle N is congruent to angle N because it is reflexive. And this is something from first semester. Now we're able to prove this is similar because of AA similarity. We know two angles. So let's pick a triangle. I'm going to pick the big yellow one and say it's LMN. Now, what's the name of the green triangle that corresponds? L corresponds with O, M with P, N with N. Okay, so we're finished. Next one. All right, so we're looking for either two sets of angles or one set of angles with the two sides that are proportional, or just three sides. So when you look at this, I see some weird stuff going on here in the middle. I see some angles that are vertical, if you remember that word. Do you guys see how they mark these two as being congruent? Are those inside the triangles? And hopefully you're saying no. So honestly, that's extra information that we don't need. And it's like a distractor. What we need is they do tell you this one and they tell you this one. So that's good. We have one set of angles that we can use. Now, do we have another set of angles? Does this mean parallel? The little parts I circled, that does not mean parallel. That means congruent. So you can't do like alternate interior angles, kind of like you did on number 1 here. You can't do that. So, I mean, you have 3 choices. Can you prove another angle, or can you prove two sides? And it would have to be the two sides that come together to make that angle. Can you prove they're proportional? And we can't. So if you can't prove it, then you're going to just say it is not similar. And, you know, what's the reasoning? The reasoning is you need another angle. Because, I mean, there's no other information. So we need another set of congruent angles. All right, going on to number 5. So when I look at this, I immediately see they both have a right angle in common. That's good. Do they have sides provided? And they do. Notice it is the sides that come together to make the angle. So this is potentially SAS. Now you need to show your work and show that the sides are proportional. So you're going to say 28 corresponds with what? And you're going to say 14. And you're going to say 10 corresponds with what? And hopefully you say 5. Now those reduce, those simplify to 2. Remember, K means scale factor. So they have the same scale factor, which means they're proportional. So how should we prove this? You have the angle in the middle, the sides on both sides. So this is SAS, similarity. Put a triangle in any order, T, V, U. And then put the next triangle in corresponding order. The first triangle, I could have picked any order that I like. T corresponds with U, V corresponds with X, and U corresponds with W. Okay, last one here. I don't see any angles listed, so I just see side lengths. So let's test the sides. There are 3 sides here. The 26 corresponds with 13. The 26 corresponds with the 13. And the 30 with the 15. Now, what's the scale factor? They're all 2. So are they proportional? Sure, they're proportional. And we're going to have to state how. It's by SSS. We know only the side lengths. And if you're asking, do we have to show these both? The answer is no. As long as you list one of them, you don't have to repeat the same information. Okay, congruency statement time. Let's pick it. The first triangle, put it in the order we want. N, M, L. The second triangle, N corresponds with, now technically you could say O or P because they both would be correct at this point. Q would have to be your next letter no matter what. And then I'm going to say P. So technically the O and the P could be flipped. Okay, identify the similar triangles in the figure. Okay, so when you look at this, hopefully you do see 3 sets of triangles. There's this little one, and this little one, and the big one. Okay, so, and I'm going to be honest, I don't like this picture because it looks distorted to me. I'm going to kind of redraw this just a little bit. And this is typically how your pictures are going to look. Now the first picture is supposed to be scaling, which means all the sides are different, but it's kind of hard for me to see it. This picture, it's going to be much easier to deal with. Okay, so this is D. No, it's not. Hold up. This is B. And then A, D, C. There we go. Okay, so let's put the first triangle in any order. And I say first triangle, I mean the big one. So I'm just going to say ABC. Now, here's the confusing part. We have to look at the order. When you look at a triangle that is scalene, there's the longest side, which is the hypotenuse, which goes, this is the hypotenuse. And I know this because it's directly opposite of this right angle. And then we have 2 legs. And these legs, one is short and one is long. So you have hypotenuse, and you have short leg, and you have long leg. That's how I refer to them. So if I go in this order this way, what legs did I just go around? I went down the long leg, across the short leg, and then back up the hypotenuse. So that's my order. Long, short, hypotenuse. Okay, so we're going to do that same order when we figure out the next few triangles. So I'm going to look at the medium size one here. I need to find the long side. So right here, this is the long side. From here, I'm going to come around to this short side and then go back up to the hypotenuse. That's short, and that's hypotenuse. So that's the order we're going to go in. So I have triangle ADB. All right, so let's try this again with the tiny triangle. Find the long side. On this little triangle here, where's the long side? Well, when I say long side, I should say long leg. I'm sorry, long leg. So this is your long leg, this is your short leg, and that's your hypotenuse. So we're going around like that. So the order is B, D, C. So guys, there's other ways to do this. This is the way that I've had most luck with in teaching and kids actually doing well and understanding. So you're just going to have to give it a try and we'll go over it in class. All right, so yay, we're almost done. Okay, so the next one's about the Eiffel Tower. Okay, now these are fractions. We're going to write a proportion. A 1.6 tall meter woman stands next to the Eiffel Tower, which we don't know how tall that is. At the same time of day, her shadow, which is down here, is 0.5 meters. And at the same time, the tower here has a shadow of 93.75. So how do you find x? So this goes back to, a lot of the lessons we've had so far. This is not just something about today. It's just matching up things, honestly. So we have the actual height and we have the shadow height. And labeling this might help you. So what's the actual height of the person? And that's 1.6 meters. How tall is her shadow? And that's 0.5. Okay, so we're going to do the same thing for the tower. The actual height is x, and the shadow height is 93.75. Okay, so now we're going to cross multiply. So 0.5x equals 1.6 times 93.75. All right, so that requires a calculator. 1.6 times 93.75. All right, so I get 150 even. Now we're dividing by 0.5. And I get 300. So what's the unit? The unit is meters. This is how tall the tower should be. All right, so we are finished. Let me know if you guys have any questions.